A line plot, which is also called a dot plot, displays data on a number line. You can use line plots to find measures of center or measures of spread because line plots contain all of the numbers in a data set. The line plot on your screen shows the shoe sizes of 7th grade students. Each X on your line plot represents a student in this case. So an X right here on 4 means that we have a student who has a shoe size of 4. There are 2 X's here, which means I know that there are 2 students in 7th grade who have a shoe size of 4. To make a line plot, the first thing that we need to do is make a number line. I can see from the numbers on this data set that my smallest number is 5 and my greatest number is 10. So I need a number line that at least goes from 5 to 10. For this, I can use a simple number line that goes from 1 to 10. Now, when I put my data on my number line, all I have to do is put a point or a dot or an X to represent each number. So my first number is 6, and I'm going to cross it off to show myself that I've already used that 6. And I'm going to go to 6, and I'm going to put a point above 6. Next, I have 8, so I'll go to 8 and put another point above 8. Then I have 9, so I'll go to 9 and put a point. Next, I have another 8, so I go to where my 8 was, and I'm going to put a point above that one. Then I have 7. Next, I have 8. Next, I have 5. Next is 7. Then 9. Followed by 2 10s. Then another 8. 5. 8. 9. And 7. So when I look at my line plot, I can see that every dot on this line plot represents a student who attended the Chattahoochee Summer Program. I can use this to find measures of center or measures of spread because I have all of the information that I need on my line plot. When we're analyzing a line plot, we can do things like finding measures of center and spread. So we can find mean, median, mode, range, and interquartile range. To find mean, we are going to add up all of the numbers in our data set. So for this, I see that I have 4 1s, so I would add 4 1s. I have 1 2, so I would add a 2. I have 2 3s, so I would add 3 plus 3. I have 3 4s, so I would add 4 plus 4 plus 4. And then I have 3 5s, so I would add 5 plus 5 plus 5. So the first step in finding mean is adding all your numbers. The second step is to then divide by the number of items in your data set. Well, I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 X's. So I'm going to divide by 13. So when I add all of these numbers, I get 39. And then when I divide 39 by 13, I get 3. So that means that the average or mean number of shells collected by students is 3. Now to find my median, I have a choice. I can use my number line, or if I don't like that, I can write out a list of my numbers in order from least to greatest, and I can do it that way. To use my number line, I would start at my least X, which is 1, and I would cross it out, and my greatest, which is 5, and cross it out. And then I'm going to continue, 1 from the front and 1 from the back, until I get to the middle. So now I'm done with my 5s, so I've crossed out a 1. Now I'm going to go to 4s. Now I'm going to do 2 and 4, 3 and 4, and now I've noticed that I have 1 X in the middle, and this X is at 3. So that means that my median is 3. To find the mode, I'm going to find the number that occurs most often, Well, on a line plot, that's easy to spot because the number that occurs most often is the number that has the highest line. So when I look here, I see that this line is the largest and it belongs to 1. So that means that 1 is my mode. Now to find range, I find my least value and my greatest value. So my least value on my number line that has an x is 1. The greatest value on my number line that has an x is 5. So the range in my data set is 5 minus 1, which is 4. Now to find the interquartile range, it might be very helpful if I do list out my numbers because I need to be splitting my data set into 2 different groups. So I have, again, 4 1s, a 2, 2 3s, 3 4s, and 3 5s. Now, when the first step in finding my interquartile range is finding my median. So we did that before, but even if you do this with a list, you can cross out 1 from the front and 1 from the back until you get to the middle. And when I get to the middle, I notice that 3 is the only number in the middle. Now, that splits my data into a lower half that does not include this 3 because this 3 is the median, and an upper half that again does not include that 3. Now I need to find the median of each half. So I'm going to find the middle number of my lower half by crossing out 1 from the front and 1 from the back until I get to the middle. Now in this one case, I have 2 numbers in the middle, so I need to find their median, and I would do that by adding them together. 1 plus 1 gives me 2, and then dividing by 2. So 1 plus 1 is 2, and 2 divided by 2 is 1. So that means that the median here is 1. I'm going to do the same thing with the numbers on my upper half. So I'm going to cross out 1 from the front and 1 from the back until I get to the middle, and I notice that I have 2 numbers in the middle here. So again, I will add them together, 4 plus 5, which gives me 9, and then divide by 2. 9 divided by 2 is 4.5. So my first quartile here is 1, and my third quartile is 4.5. To find my interquartile range, I'm going to take those and I'm going to subtract. 4.5 minus 1, which gives me 3.5. So the interquartile range here is 3.5. I can also describe the shape of a line plot. When I'm describing shape, I am either going to use terms like symmetrical, or I'm going to use terms like skewed, or I may even describe some clusters that I see. In this first line plot, I see that a lot of my data is clustered here between 1 and 4. So I can say that there is a cluster between 1 and 4, and I can see that because my data is grouped between 1 and 4. I do have a point at 0, but it's only 1. And just like I have a point at 5, but it's only 1. But I notice that from 1 to 4, I have several points. So these are going to represent a cluster of my data. I can also see that this data is not symmetrical, but I notice that I have a cluster over here to the left, and if I were to draw a line to represent this, it would go like this. And it seems as if I have a tail over here to my right. This would mean that my dot plot is skewed right, because our dot plots are skewed based on where our tails are. For our next dot plot, you can see that we have a cluster here from about 9 to 12. And if I were to put a line here to represent this data, it goes like this, which means that this data has a tail that goes to the left, so this data would be skewed left. For our final dot plot, you can see that there's a cluster around pretty much everything from 3 to 7. And if I were to show this, I would find this, which is a curve. Now, I cannot say that this is perfectly symmetrical, because if I were to fold this right here at 5, my 3 and my 7 would line up perfectly, but my 4 and my 6 would not, because there's an extra point here that 4 doesn't have. But this would be almost Symmetrical. It does not have a tail, so it is not skewed, so we can say it is close to symmetrical.